This video is going to look at something called constants of proportionality. Constants of proportionality are similar to unit rates. I'm just going to start the video off with two unit rate examples. This first example looks at coffee pods. And when you go to the grocery store, you can see there's different sizes of coffee pods. You've got like maybe the smaller boxes with 24, medium boxes with 48, and a large box with 96. And the question becomes, what's the best deal? If you look at the price of the box of 24, it's $19.99. So it looks like it's the cheapest, right? In terms of overall price, it is the cheapest price, but what would the price per coffee end up being? They're telling us already it's 83 cents. How do they do that calculation? A lot of grocery stores do this calculation for you, and if you look really closely at the price tab, you'll see it, but not all do. How are they getting the 83 cents? All they are doing is they are taking the price and dividing it by how much you're getting. So they're taking $19.99, dividing it by the 24 coffee pods. So if you look at the overall price, $19.99 is the cheapest. And if we look at the overall price for 48, $67, that's the most expensive. 96 coffee pods is $49.52. Ideally, assuming you're going to use everything, you don't just want to look at the overall price. You want to look at the price per unit. And that's exactly what a unit rate means. How much for one? When you do that calculation, this calculation here, you take the price and divide it by the quantity, you can see that the box of 96 is actually has the lowest unit rate, the cheapest unit rate. Even though you're going to pay close to $50, which is a lot more than 20, the cost per coffee is only going to be 52 cents compared to 83. Okay, so using that idea of the unit rate to compare to find the best deal, you take the money and divide the quantity. I want you to pause the video in a moment and try this one. Which juice is the best option? So you could buy a 2-liter bottle of juice for $6.78, or you could buy a 1.54 liter for $4.48. You could buy a 4-pack of 340 mils for $3.90, or a single 340 mil for $1.78. What is the best buy? When you're comparing things, they have to be the same unit. Okay, so we already said best buy is the money divided by the quantity. So if I look at these 4 options, they're all in dollars, but the units, 2 of them are in liters, and then 2 of them are in milliliters. In order to compare, I need to have them in the same units. It'll be easiest to find the price per liter. So you're going to take the dollars and divide the number of liters. Okay. You might have to think and remember, how do you convert 340 mils to liters? But pause the video, see what you get for this, and then once you have an answer and you think you know the unit rate for all 4, the best buy will be the lowest price per liter. Resume the video and see if you were right. Okay, so here's my calculations. You can pause if you need to, but the $4.48 for the 1.54 liter juice was the best buy. It was $2.58 per liter. So it was the lowest cost per liter out of all 4 options. Again, it's assuming you're going to drink all that juice, but that's the best buy. Okay, now that we've reviewed that, I'm just going to introduce a term. It's constant of proportionality. It's very similar to a unit rate. It's how much for one. A relationship is proportional if an amount times some number will always equal the other amount. And I'm going to talk about that more on the next slide. That number, right? So it said if an amount times some number, that number is called the constant of proportionality. Might be a little bit confusing now, but as we go through the next few slides, hopefully that it becomes a lot more clear. constants of proportionality or proportional relationships can be seen in three forms. They can be seen from a graph, they can be seen from a table, or they can be seen from an equation. In a graph, you've got your y-axis and your x-axis. A proportional relationship will always go through the origin. The origin is this point right there. The line could go up really steep. It could go up really slowly. It could be going down. Any single line that goes through that origin would be proportional. Oops. Okay, so if you have a graph and it's asking, is it proportional? You're looking to see, does it go through that origin? Does it have the point 0, 0 on that line? In a table, so a table, sometimes you call those a T-chart. Where you have your X values, which may have been called inputs, your Y values, which may have been called outputs. If the Y values are all a multiple of the X values, it is proportional, meaning to go from any X value to the Y value, all you're doing is multiplying by the same number, the constant number. It would be proportional. And we'll look at examples in a few moments. Okay. In an equation form, it could be one of two forms, and I'm just going to write them at the bottom. If you have a line or the equation of something that's y equals some number times k, or y over x, oops, sorry, that should have said some number times x, or you have an equation y over x equals some number, then it is proportional. Okay. When we're looking at these things, and I'm just going to go back a slide because I highlighted it at the term the number. The number is called the constant of proportionality. The constant of proportionality here is this number. Whatever that multiplier is from the table, that's the constant of proportionality. If it's a y equals a number times x, that's the constant of proportionality. Or if you take your y value and divide your x value, oops, keep messing up, that there is your constant of proportionality. And we will look on a table. How do we get that from a table? Okay. But proportional from a graph goes through the origin. On a table of values, your y values can all be calculated by taking the x and multiplying it by the same number. In an equation, it's y equals just a number x, or if you take y and divide x, you get the constant number. Okay. Just going to go through this quickly. I actually skipped it in class, but here we have a table. Is this table proportional? If you look, it is, because 1 times 12,800 gets me that number. 2 times 12,800 gets me that number. 3 times 12,800 gets me there. Every y value, all of these values here, are calculated by taking the x and multiplying it by 12,800. So this is a proportional relationship. Okay. The constant of proportionality is 12,800. The other way you could do it, and this is what this part here says, to calculate the constant of proportionality, you can take the y values, because maybe like some numbers might be harder to see depending on the table you're working with. You can take your y values and divide the x. And see, when you do that division, do you get the same number every time? And here you do. You get 12,800. So that is proportional. Okay, so from a graph, proportional graphs from a few slides ago, proportional graphs go through the origin. They go through 0, 0. The question here is saying which ones are not proportional, meaning they don't go through the origin. Well, this one here doesn't go through the origin, so that is not proportional. This one here, actually this one is not proportional as well. And we don't see this a lot in grade 9, but I wanted to show you this because I should say it's a line, a straight line going through there. That red thing there is not a straight line. So what does that mean? This goes through 0, 0. This goes through 0, 0, 0, 0. So both of those two middle ones are proportional. And if you want the constant of proportionality, you can find a point. There the y is 1, x is 2. So your constant of proportionality, you can take your y value, divide the x value, and you get 1/2 or 0.5. We'll see that in a little bit. But a proportional graph goes through the origin and is a straight line. If it's not a straight line, it's not proportional. If it doesn't go through the origin, if it doesn't go through 0, 0, it is not proportional. What about tables? We said a table is proportional if every y value is the x value multiplied by the same number. If I look at that first table, 5 times 4 is 20. 10 times 4 is 40. 15 times 4 is 60. 20 times 4. Oh, so I multiplied everything in that, every number in that x column by 4. So this one is proportional. And the constant of proportion is 4. It's that multiplier. The other way, if you're not so strong with the times tables, you could take your y values and divide x. And you're still going to get that constant of proportion, which is 4. What about the second one? Okay. Can I multiply every one of these x numbers by the same number to get the y value? Well, 0 is a harder one to look at because 0 times anything is going to be 0. 3 times what is negative 6? Well, you could do negative 6 divided by 3, and you'll see it's negative 2. Is 10 times negative 2 20? Yep. 15 times negative 2 is negative 30. 21 times negative 2 is negative 42. And 0 times negative 2 is 0. So this one is proportional. And the constant of proportion is negative 2. What about this last one? Well, okay, maybe the first one I can say 1 times 8 is 8. 2 times 8 is not 11. So this is not proportional. I don't need to check all the other values out because right away that first one, the first two didn't work out. 8 divided by 1 is 8. 11 divided by 2 is 5.5. Sorry, 8 divided by 1 is 8. Right there, they're not the same. They don't have the same constant of proportionality, so it is not a proportional table. What about equations? From our first slide a while ago, it said a relationship is proportional if an amount times some number will always equal another number. So there's two that are proportional and two that are not. This first one is proportional, right? Because I'm multiplying every x value by 5 to get y. That there says the same things in the table. If I take x and times it by 5, I'm going to get the y value, right? In a table, that's all that it means. The second one is not. And it's not because of this squaring of a number. If you were to test this out with some values, and I try 1 and 2, 1 squared is 1, 2 squared is 4. Right away, you can see there's no constant of proportionality there. The third one, this one is. This one is, and all this one's saying is that every y value is the x value times negative 3.2. The third one is not, and it's not because of that addition piece. A few slides ago I said equations, if you just have a number times x, the number can be a whole number 5, the number can be a negative, the number can be a fraction, but if you just have a multiplier, if you just have a coefficient, then it is proportional. As soon as you add something into that equation, then it becomes non-proportional. It's not proportional anymore. Okay. The constants of proportionality here is just that multiplier in front of x. So in this first one that is proportional, the 5 is the constant of proportionality. In the y equals negative 2 over 3, negative 2 over 3 is the constant of proportionality. Okay. So here we have two graphs, graph A and graph B. They're both proportional. They're both direct proportions because they are lines that go through the origin. The graph, the table, and the equation for graph A all say the same thing. So that red line for graph A, y equals negative 1 over 4x, and the table of values with those x's and y's all are the same thing. They're all representing the same relationship in different forms. The same thing on the lower graph. The red line, y equals 5x, and the table all say the same thing. They all say they're proportional. So if we look at that first one, pen has died. So let's try to do this with my finger. Okay, in this first graph, it's proportional because it goes through 0, 0, and it's a line. In the equation, it's proportional because it's just x with a multiplier. In the table, it's proportional. Zoom back out. Because if I take the y value and I divide x, 1 divided by negative 4 is negative 1 over 4. 1/2 divided by negative 2 is negative 1 over 4. If I do those divisions each time, 1 divided by negative 4, 1/2 divided by negative 2, oh, remember dividing fractions, oops. Dividing by negative 2, I multiply by the reciprocal, I get negative 1 over 4. That negative 1 over 4 here or here is my constant of proportionality. How could I get that from a graph? The same way. find a y value and divide the x value from that coordinate. So if I look at this coordinate over here, the y value is 1. The x value is -4. If I pick this coordinate, the y value is -1. The x value is 4. So I can get that constant of proportionality all three ways. In the second example down below, the constant of proportionality is that 5. And if I look at the table, I pick any point, maybe I pick this point up here, take your y value of that point, which is 15, divide the x value of that point, which is 3, and you get 5. From the table, same thing. Take your y values, divide your x values. And you're going to get 5 every single time. Okay, so let's find the constant of proportionality for each of these. So these are 3 different relationships. If you look at the table, you could think 4 times what number is -2? 6 times what number is -3? Or you can take your y values and divide the x values. So I get -0.5 or -1/2. -3 over 6, -1/2. -5 over 10, -1/2. -19.5 over 19, -1/2. So all of those so that table is proportional, and the constant of proportionality is -1/2 or -0.5. Same thing. This equation of the line, it's just x being multiplied, right? The x's are being multiplied by a number. There's no adding or subtracting, and there's no exponent. So that there is the constant of proportionality. If I had a number here, it's no longer proportional. If I had an exponent here, it is no longer proportional. What about from this graph here? So it's a straight line that goes through the origin. There's 0, 0, where the x and y axis meet. So it is proportional. The constant of proportionality I can get by taking the y value and dividing the x value. So I could use this point, this point, this point, or this point. Any of them will get me the same value. Just be careful here. This is not the value 1. Even though it's the first line, 1 is way over here. So it might be easiest to use this bottom point where your y value is -4 and your x value is 1. The middle point, the y value is -2. The x value up there is 1/2. I could still get there because we know how to divide fractions. -2 divided by 1/2 is the same as -2 times 2 over 1, and you get -4 over 1. -4 over 1 just means the constant of proportionality is -4. Okay, so that's the idea of constants of proportionality. Let's use some proportionality to solve some problems now. Samantha's painting her bedroom. 1 liter can of paint is $30, and a 3.7 liter can costs $89. Which has the lowest cost per unit? So this is going back to how we started this. What you want to do here is you want to take the price and divide it by the quantity. So 1 can, and still not working. So that first can is $30. Oops. can, it's $30 for 1 liter. That's $30 per liter. The second can is a lot more money. It's $89, but I get 3.7 liters. What is $89 divided by 3.7? You get 24 0.054051, only 2 decimals for money. Okay. So the second one is 24.05 per liter. Which has the lowest cost per unit? This one, the 3.7 liter. Even though you're going to pay more, the cost per liter is less. When would you normally purchase the can with the higher unit price? Well, if you only need 1 liter of paint. Right? If you don't need that 3.7 liters, you're not going to spend the extra money on that. Okay. Another one. Jason's comparing data plans for his cell phone. Which plan offers the best rate? What other factors should he consider besides the monthly cost? So he's got 3 plans. One plan, $80 for 30 gigs, $85 for 35 gigs, $125 for 50, $175 for 100. Well, find the cost per gig, right? So 80 over 35. $85 divided by 30. $80 for 30 gigs, 85 for 35, $125 for 50 gigabytes, and $175 for 100. Again, I'm taking the money and I'm dividing the quantity. The quantity in this example is gigabytes. I apologize for the messiness. My pen has died and it's not charging. So that first plan, the cost per gig is $2.67. 67 cents per gigabyte. My second plan, $85 divided by 35 gigabytes, that's $2.42. My third one, $125. I'm getting 50 gigs for that. That's $2.50 per gigabyte. And 175 divided by 100 is $1.75 per gigabyte. So the lowest cost per gigabyte is that fourth plan, $175 for 100 gigs. So I'm only paying $1.75 per gig. Other factors he should consider is how many gigabytes does he need? Very few people need 100 gigabytes. So if you don't need it, don't pay more for it. Leisha currently works 30 hours each week and earns $1,155. Her hourly wage stays the same, but she starts working $40 per week, 40 hours per week. How much will she make in a 40-hour week? Use the unit rate and the constant of proportionality. So, she is currently making $1,155 when she works 30 hours. The unit rate is how much she's making each hour. So you take the money, divide it by the quantity of hours she's working, and she is making $38.50. That unit rate is the constant of proportionality. Every hour she works, she gets paid $38.50. So how much will she make in a 40-hour week? Well, if she makes $38.50 each hour and works 40 hours, you can multiply that by 40, and she will now make $1,540 a week. Okay, so that first calculation there, that is a unit rate. It is also the concept of proportionality. I'll skip that. Skip that. Okay, last example here. A recipe for 4 people needs 300 grams of dry pasta. How much would be needed for 1 person? So the recipe says this, you're cooking for 1 person. So you want the amount for 1. So take the amount that's for 4 people and divide it by 4. Right? 300 grams for 4 people means 75 grams of pasta per person. All right, we took the grams and divided by the people. Identify the constant of proportionality. Well, the constant of proportionality is that 75. How much dry pasta is needed to feed 26 people? Well, take that constant of proportionality, 75 for each person, for 1 person, but you got 26 people. So multiply that by 26, and you need 1,950 grams of pasta to feed 26 people. And you should put a therefore sentence, but trying to use my finger here, it won't be, you won't be able to read what I write, but you would want a sentence that would say something like, therefore to feed 26 people, you would need 1,950 grams of pasta. So that's the idea of proportionality. There are some homework questions you can practice.